Uh, the other thing about vectors is that they have a direction and that they have a magnitude. How do we find that direction and magnitude in a simple a vector that only has two components? And we will call them the I component. There's the I component of this vector. It is 4 at the moment, so this is 4i. And here is the j component. So the I component is our x value, and our j component is our y value. In this case, it doesn't have to be x and y. It doesn't have to be our nice, simple perpendicular axes like this. But in most cases, that's what we can break components into or forces into. We can any force, to work with a force, which is a vector, we break it up into its horizontal component and its vertical component. So in this case, it is 4i. The j component is going to go up this way, and it's going to go up 8. So that is the I component. That is the j component. If we want to look at that vector in component form, that's what it looks like. So the vector v is 4, 8, and that equals 4i plus 8j, where I is just a 1 unit vector in the x direction and j is a 1 unit vector in the y direction. And that is a fairly standard form. If there was a z, if there was a third direction, then there'd be a third letter, which is usually k. But in this case, that's our vector. We can write it as 4, 8 down this way. That says it's a vector if we write it like this. Don't get it confused with the point 4, 8, which would be written horizontally. Because it's written vertically like this, we know it's a vector, and it has a v. Vector v is 4i plus 8j. If we want to see the magnitude, well, the magnitude is just the distance. How do we get that? It's just Pythagoras, basically, the square root of 4 squared plus 8 squared. And how do we get the direction? The direction is just going to be the tan of theta. So the tan of 8 over 4, y over x. That's very, very similar, especially in 2 dimensions, to the polar coordinates that we did last time. So the direction and the magnitude is basically the polar coordinates. So there we go there. The vector is the square root of 4 squared plus 8 squared. And how did we get that 63 degrees, where this is in degrees? It's just going to be the tan, or the arctan, or tan to minus 1 of 8 over 4. If we change this a bit, let's make that, and we'll turn that into a negative. So it's going to have an x component of 3, so it's going to come out here, and then the y component is going to be minus 4. So in the long run, this is going to be down here. But what you're going to have is the vector is going to be 3 minus 4 in that vertical form, or 3i minus 4j. So there's the I vector in the I component. There's the j component. To see it in vector form, there's the vector there, or 3 minus 4, or 3 in this direction, the x direction, and minus 4 in the y direction. If we think about the magnitude, that's a right-angled triangle, so it's going to be 3 squared plus 4 squared is 25, and then we're going to take the square root of that. So it's going to be 5 squared, and the magnitude is going to be, the direction is going to be this angle there. So it's going to be around to about 300 degrees, just around 300 degrees somewhere. And there it is. The magnitude is 3 squared plus minus 4 squared, which is 5. In terms of degrees, again, it's just polar coordinates. This is going to be tan theta, which is tan theta equals opposite over adjacent, which is going to be the 4 over 3. And then you've just got to remember that it's in this fourth quadrant, so it's 360 minus that. Hope that simplifies stuff a bit. Thanks.